All right, this is basic statistics. We're looking at the chapter 4 note packet. So let's jump in. It's sample spaces and probabilities. So we're probably have a little bit of exposure to probabilities if you've been, that's chances of an event occurring basically. So let's take a look. We have what's called probability experiments. That's a chance process that leads to a clearly measurable result called outcomes. Turn that off so we don't hear that the whole time. So an outcome is the result of an experiment. So let's take a look at sample space is a list of all possible outcomes. So if you are going to flip a coin, the list of possible outcomes would be heads or tails. If you're going to roll a die, when it's a single cube, it's called a die. When there's two of them, they're called dice. So if the single die has 1 dot or 2 dots or 3 dots or 4 dots or 6 dots. So that is a list of all possible outcomes for a single die. Answer a multiple choice question. So most multiple choice questions usually have A, B, C, or D. That obviously can vary. The test that you just took for me, there were 4. So we're going with 4, A, B, C, and D. You toss 2 coins. So now if I toss 2 coins, now we could get heads, right? So heads on both of them, or we could get a heads and a tails, or we could get a tails and a heads, or we could get a tails and a tails. And so there's actually 4 outcomes. So remember, sample space is a list of all possible outcomes. So if there's 2 events happening, there's going to be more than just heads and tails. There's actually double, right? Let's take a look. Select a card from a regular deck. So if you select a card from a regular deck of cards, there could be, and I mean, we're not going to list them all. We'd have 52 different listings here. So we could have 2 of spades, or 2 of clubs, or 2 of diamonds, or 2 of hearts. And then we just pick up again with 3 of spades, 3 of clubs, and so on. That would go on forever, all the way until we get, not forever, until we get up to king and then ace, and then that would be it. There would be 52 actual individual things listed, though, from selecting a card from a standard deck of cards. If you roll 2 dice, now there are a bunch of outcomes, so I'm going to actually list them, like 1, 1. We could get 1, 2. We could get 1, 3, 1, 4, 1, 5, 1, 6, and then 1, or not. That's all the ones. So then we could get 2, 1, and then we would list all of those. 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and so on. There would actually be 36. These are really bad. So when you do set notation, that's what these squiggly little lines are supposed to look like. It's supposed to look like a big little guy, and then like that kind of squigglies. All right. So there's actually 36 possible outcomes, all the way up to 6 is where it would stop. And so we could make a chart for that if we wanted to, like 1, 2, 3, 4, 5, and 6, and 1, 2, 3, 4, 5, and 6, and then fill them in, like 1 and 1 is 2, 1 and 2 is 3. Like we could say what they actually add up to. This is what happened, and that's what they add up to. And so we will examine that in some of the homework. All right, page 2, we have what's called a tree diagram to go with this stuff. And a tree diagram is a list. It's a way to build the sample space in a more complicated problem. These were all pretty easy problems. Even this, there were 36 of them, and this, there were 52 of them. But it's pretty, you don't have to really rack your brain on figuring out what's going to happen when you just roll 2 dice. What are all possibilities? Where sometimes the events could be a little more complicated, or maybe we're going to talk about 3 or 4 events, and then it balloons up. And so they have what's called a tree diagram, where you kind of think of all possible outcomes. So let's take a look. Example, if you toss a coin 3 times, what would be the sample space? Now, we already did toss a coin once and toss a coin twice. So this time they want us to toss a coin 3 times, and it gets a little more complicated. So look, the first toss, you could get heads or tails. So this is like a map of everything that could possibly happen. Then, so on the first toss, I could have got heads, but then on the second toss, I could get heads or tails. And then I could have gotten tails first, and then heads or tails. And then on the third toss, heads or tails, heads or tails, heads or tails, heads or tails. And so when we look at the end of each one of these branches, it's like a possible scenario. And so if this happened, heads, heads, heads. So that's what's at the end of this branch. Heads, heads, tails. Heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And tails, tails, tails. So there's actually 8 distinct possible outcomes when you toss a coin 3 times. And then if we list them in as a sample space, you put it in this form, but then we're just going to copy these down. So heads, tails, heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. I'm gonna run out of room. Tails, tails, heads, and tails, tails, tails. Sorry, I ran out of room. I ran out of board. So, list of all possible outcomes is the sample space. Let's find probabilities. So if we find probabilities, that's the number of ways it can happen over the total amount of things, total possibilities. So look, on this first one, find the probability of drawing an ace from a deck of cards. So in a standard deck of cards, there are 4 aces, and there are 52 cards. And so when you're talking about probability, this is the number of ways it can happen, and this is over total possible outcomes. It's different than odds. A lot of people they mix those up, or they say they're the same thing. They're not the same thing. Odds are the number of ways it can happen against the number of ways it can't happen. So if you wanted the odds of pulling an ace, it would be 4 to 48. If you want the probability, it's 4 out of 52. So in other words, these 52 include those 4 aces as possible outcomes. When you're doing odds, it's the ways it can happen against the ways it can't happen. And so those are different. All right, so 4 aces over 52 cards. If we reduce that, we could divide by 4 and make it 1/13. That's fine. We're a base 10 society, so a lot of times it makes more sense to us if we divide that and make it into a percent. You say 1 chance out of 13. And that doesn't mean a lot to a lot of people, but if you say 1 divided by 13 is 0.07692, if you say about 8%, there's an 8% chance of that occurring. Most people can really wrap their head around that, 8%. But if you say 1 out of 13, you know, they're the same thing. They're interchangeable, but a lot of people are a little confused when it comes to fractions, where percents were pretty good because we're base 10 society. So find the probability of getting 2 heads when you toss 3 coins. Well, we've got the sample space right here. So the probability of getting exactly 2 heads means you identify how many times did we get 2 heads. There they are, there they are, there they are. So 1, 2, 3 times. That's how many ways it can happen over 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. So 3/8 would be the answer there. All right, find the probability of getting 2 or more heads. So that means 2 or 3, right? So probability of 2 or more. When you toss a coin 3 times, that really means 2 or 3 because it's only been tossed 3 times. So we've already got all the 2s and then 1 more on there. So that would be 4 out of 8 or 1/2, right? We reduce it, divide by 4, divide by 4. All right, so those are the probabilities, the chances of those occurring. Oh, there's one more. It's on page 3. If a whole number from 1 to 100 is randomly selected from a what is the probability? The number is 14. So you have 1 through 100. The numbers are written and put into a hat and mixed up, and then you pull one out, only one, and they want to know what are the chances the number is 14. So the probability of getting the number 14 when it's only 1 out of 100 is 1 out of 100. All right. Okay. When we talk about complementary events, that's everything that isn't the other thing. So if I said the probability of getting a 14 is 1/100th, the probability of getting a not 14 is 99/100ths. So it's very likely that you're not going to get 14, and it is not very likely that you're going to pick 14 when you pull it out. It could happen, but it's not a very likely scenario, right? And so lots of times, lots of teachers do it where they say, the probability of getting an even or the probability of getting an odd when you're like 100 numbers. And then it's 50 out of 100 and 50 out of 100, which is 1/2 either way, which those are complements of one another, but they don't always have to be the same. Like when you use even and odd, then a lot of times students think, so it's got to be always the same. No, it often is not the same. This was not the same. The probability of 14 was 1/100th. The probability of not 14 is 99/100ths. So it's everything that isn't the other one. So let's take a look. The complement of having at least one success would be to have no successes. For instance, what is the complement of having at least one hit in 5 at-bats? Well, 1 hit in 5 at-bats is, wait, I skipped the first example. Let's look at the first example. If the probability of dying from cancer is 8%, what's the probability of dying of something else? So let's take a look at that. So if the probability of cancer is 8%, then the probability of not cancer is 1 minus 0.08. It's the opposite, or whatever would add up to 1. So 92%. So there's 92% chance that you're not going to die from cancer. note the complement of having at least one success would be to have no successes. Okay. And then there's a, for instance, what is the complement of having at least one hit in 5 at-bats? At least one hit. Remember what that means. That means 1 or 2 or 3. So look, they don't want us to actually find it. At least one hit in 5 at-bats. So that would mean the probability of 1 or 2 or 3 or 4 or 5. That's at least 1. That's 1 or 2 or 3 or 4 or 5, right? And so instead of finding each individual probability and then adding them together, a lot of times it's easier just to say 1 minus the probability of none. Because look at the entire sample space. What's the sample space with 5 at-bats? If you're just talking hit or miss, you could have 0 hits out of 5, or 1 or 2 or 3 or 4 or 5. So if this is the sample space in its entirety, and they want to know this, and this, well then all you do is find the probability of none and do 1 minus that. And so that's what's going on there. So the complement is having no hits in 5 at-bats. And that's a good technique. Even if they said more than 2 or more, it would be easier to find 0 and 1 and add them together and take it away from 1 than find 2 and 3 and 4 and 5. And so that's using its complement. All right. For instance, suppose we roll a die 500 times and these rolls 100. Oh, so now we're on to empirical probabilities. Empirical probability, so bottom of page 3 of your note packets, chapter 4. Empirical probability means basically an experimental probability. Like you run an experiment and then you use that experiment to predict what's going to happen. What is the probable cause of it occurring? Or probable chance of it occurring. For instance, suppose we roll a die 500 times. In those rolls, we get 100 1s, 100 2s, 100 3s, 150 4s, 25 5s, and 25 6s. So 5 and 6 didn't happen that much. So if they want the empirical probability of getting a 6, so that would be 25 out of 500. Based on that experiment, it would only be 1/20th instead of what we would have expected, where we would expect it to be 1/6 for each one. Not 1/20th, but that's the difference between theoretical probability. Theoretical probability is what should happen, and with the law of large numbers, what does eventually happen if you get the trials up there a lot. You know, if we make that instead of 10 rolls or 500 rolls, we make it 10,000 rolls. It'll be really close to each number an equal amount of times, and so that's. Theoretical probability is what should happen. Empirical probability is what did happen in an experiment. All right? And so suppose that in a sample of 50 people, we find 21 type O, 22 type A, 5 type B, 2 type AB. Find the probability a person has type O. So again, so we're on page 4, but the empirical probability of type O would be how many had type O? 21/50ths. And so if we make that into 21 out of 50 doesn't mean a lot to a lot of people, but if you make it into a decimal and then a percent, if you say 42%, most people understand that pretty well. 42% chance. Let's make sure can you read that? Okay, you can read that, and we're just coming up on 20 minutes. All right, so a person has neither type A or type B, and so 27 of the people have type A or type B, which means 23 don't. And so it says neither type A or type B. So that means they want to know, they want the ABs and they want the O's. So type O is 21, type AB was 2, so we're talking about 23 50ths there. So neither type A or B means 23 50ths, which is about 0.46. All right. Okay, and then subjective probability means it's an educated guess, so it shouldn't just be pulled out of the air. So what is the probability the Packers win the Super Bowl this year? I put down between 0 and 1 because I'm really no expert on how good we look this year. Like Sports Illustrated or ESPN or different sports shows, they can look at who did they draft, the likelihood of this happening, who are the coaches, what are their track records, you know, and so they kind of use combinations of the past and who they have, and then sometimes they're still not even right. It's just they can put a better probability on it than just between 0 and 1. 0 means it's not going to happen. 1 means it's 100%. So all probabilities kind of fall between 0 and 1 inclusive. And so I need a whole lot more information and data to put like a percent on there where they say, ooh, there's 70% chance or 80% chance, or they're one of 5 teams out of all the teams that might really win the Super Bowl this year. So that's what's subjective probability. But it shouldn't just be that you pulled it out of the air. You don't just look at something and go, oh, there's a 70% chance that I'm going to like the taste of the birthday cake that you got me. That's just, you just kind of pulled that out of nowhere. So subjective, there should be some calculation somewhere in there, and you should be able to argue for why you picked what you did. All right? Okay. So the next section we'll do is 4.2.